Today we're talking about equations with variables on both sides. So far we've looked at simple one-step equations. We moved on to some multi-step equations, but so far we've had all of our variables on the same side. So the first question we see here is, what is the difference between the two equations that you have? Well, if you look at the two equations that we are looking at, we have the same terms. They both have x, 10. We have a 2x, an x, and a 10, but notice the difference here is these x's are on the same side of the equation, so we could easily put them together to make a 3x. In this equation over here, they're on opposite sides. So we want to talk about how are we going to get them together so we can get all of our x's on one spot to solve these equations. So basically, when variables are on opposite sides, you first must move them by either addition or subtraction. I personally like to have us move the variables very first before we start then doing our SADMEP steps. It's not something that absolutely has to happen, but I think that it makes it easy to think of your steps in the sense of when variables are on opposite sides, you move all of the variables onto one side, and then all the numbers go on to the other side. So let's see how one of those would look. So in example 1, we have 15 minus 2x equals negative 7x. Now, it doesn't really matter which way I push the variables. I can either add them both to the right-hand side, or I can collect them both onto the left-hand side. And it really does not matter. It's totally your call. It's something that you'll decide as time goes on which way you think is best for you. In this example, I am going to move my negative 2x to the right. The reason I'm going to do that is because it's going to actually save me a step. If I actually move the negative 7x to the left, then normally we like to have our variables on the left, I would then be cluttering it again with the 15 also. But by moving the negative 2x over to the right, and I use the inverse of negative by adding 2x, I now am going to be left over with 15 on the left-hand side. And because negative 7x and 2x are like terms, I can add them together to get negative 5x. Now I have all the variables on one side. So they start out on different sides, but I move them together to get on the same side. At this point, I just do my one-step equation. I think of SADMEP, but I just have to think of what's the opposite operation or inverse operation of negative 5 times x. Multiplying by negative 5 means to divide by negative 5. I do that to both sides, and I should get x equals negative 3. Now typically we like to have our variable on the left-hand side when we give our answers. So I'm going to make one more move here and simply take the equation and kind of flip it around. Everything that was on the right comes over to the left. Everything that was on the left goes over to the right. And our answer is x equals negative 3. To do a quick check on this, again, you always want to check in your original equation. So I'm going to go back to 15 minus 2. My x's I'm going to replace with a negative 3 equals negative 7. And the x is a negative 3. And now I follow PEMDAS. So 15 negative 2 times a negative 3 is 6. And then negative 7 times negative 3 is 21. 15 plus 6 is 21. So that tells us that we know we have the right answer and we can move on. Here's two more examples that I want to look at where I have variables on both sides. The first one talks about 3 times 5x plus 2 in parentheses equals 15x. The very first thing I want to do before I start moving around variables to both sides is I have to take care of that distributive property. We know the distributive property is outside number times the first inside number. We get 3 times 5x equals 15x. We get 3 times the 2 is going to give me 6. So I've broken up the grouping with my distributive property. Now I can take a look at what's going on next. At this point I have 15x on both sides and I need to get them together. So to move the 15x, I'm going to subtract 15x to undo the positive 15x. And then notice what happens here. 15x minus 15x becomes 0. That's going to leave me with 6. But on the other side, also notice 15x minus 15x gives me 0. So I have to bring down the 0. Now we know that 6 and 0 is not the same thing. That symbol means not equal to. And when this happens, if the variables disappear and the left side does not equal the right side, we simply answer no solution. Okay? But the variables have to disappear first. On my second example, we're going to look at a problem again with my distributive property. I look at 2 times the 4y, and it's a negative 2, so I get negative 8y, and then I do negative 2 times 1, and I get negative 2, equals the negative 8y minus 2 on the right-hand side. So again, I want to get my variables together. So when I see a negative 8y, I'm going to add 8y to both sides. This time notice what happens is when I take a negative 8y and I add 8y, I get 0. Negative 8y and an 8y equals 0. And I'm left over with negative 2 equals negative 2. Well, that is true. And because that is true, what that is telling us, and this is our solution, is an infinite number of solutions. So notice the answer is not negative 2. Just because negative 2 equals negative 2, that's what's telling us that it's really any number I plug in will make this a true statement. So an infinite number of solutions means no matter what I plug in for y, the left side will always equal the right side. Whereas in example A, whatever I plug in for x, the left side will never equal the right side. So we're going to get some different possibilities. In the first example, we had one answer, x equals a negative 3. But in the second example, part A, we got no solution, meaning it will never work. In part B, we got infinite solutions, which means it will always work. On this next example, we have two circles. An important part about these circles, we can look at and we see a diameter, which is the 4x, and we also see a radius, which is half the diameter, which is an x plus 2, which doesn't really give us the information that we think we should need. However, if you look over into our directions, we got some important information right here with this word. The circles are identical, which basically gives us something that we can make an equation with. If they're identical, I can work with the information from one to equal the information of the other one. What we want to know is what is the area of each circle. Well, some things we want to kind of recall back from what we know. The area of a circle formula is area equals pi r squared. So with that, we want to look at, well, what do we have from these two? Well, because we were told that these are identical circles, I can basically make them equal to each other. Okay? So I'm going to look at the radius of each of them. I'm going to try to figure out the area of each of them. So if these circles are identical, that would mean that the radius both would be the same. Okay? So far we were given just diameter and radius. I'm going to use a formula. I'm going to focus on the radius of the green and the radius of the purple. So the radius of the green is x plus 2. Well, the radius of the purple one, so far we only have the diameter, but we know the diameter is cut in half to become the radius. It's 2 times the radius. So if I was to take 4x and divide it by 2, I would now have the radius. 4x divided by 2 is 2x. So there's the equation I want to work with. I'm comparing the radii of the two circles to find out what is this x value. Because if we have the x value, then we can figure out what is the area. So again, I have variables on both sides. I need to try to move them together. So in this case, what I'm going to do is focus on the left-hand side and move the x by subtracting x from both sides. That will remove it from the left, leaving me with just a 2. 2x minus x gives me x. So now I know what my x value is. My x value, though, is not my radius, it's not my diameter, and it's not my area. So I've got some more work to do. But I can use the radius with that x, because initially we said that one of them was x plus 2. So if I plug in a 2, I would now know that the radius is a 4. Since they're identical, I know that it's in both. But again, that's not answering the question. The question wants to know what is the area. Well, that comes back to our area equals pi r squared. But now we've got some information. Area equals pi r squared. Well, r is our 4 that we've just found, and square. Now when you remember about exponents, when I square something, or to the second power, what it means is 4 times 4. It's the base times itself, and there are 2 of them. So my area is going to equal pi 16. And typically what we do is, just like when we have numbers with variables, if we're multiplying them, we like to see the number in the front, followed by the symbol pi. So our area is 16 pi. We're not looking for times 3.14. If you come over here to our answers, they are all just left as pi, so we're okay with the answer being 16 pi. In reality, we probably should have units squared, because we always talk about units being squared in area. And lastly, in this section, we are looking at a boat traveling x miles per hour, which is obviously their speed, so that's something to keep in mind, upstream on the Mississippi River. On the return trip, meaning they're going back down, the boat is traveling 2 miles an hour faster. So that's going to be some information that we want to think about. So here we're going to use, right here, the idea of the distance equals rate times time. And this is a formula that you'll see if you haven't already seen it in your academic career. D equals R times T. Rate is our speed. So when we talk about our rate, we are talking about our speed. That is the R. So here we have a formula. We obviously are traveling the same distance. If I start down here and I travel this far to the ending point up top, and then I start at this point and I travel this far, I've gone the same distance. So we've set up an equation here where we're saying the distance is the same. What is different is the rate and the time. So if I focus on the distance upstream, well, the upstream is the blue. The upstream is traveling 2 miles an hour faster than the downstream. Now notice that our time going upstream is the 3. And if you plug in the rate, right now we don't know what that rate is. We're just going to leave it as an R. Okay? On the other side, the distance that we are traveling, the time that it's taking us, not the distance, we just said the distance was the same, is 2.5. Now we got to think about, what's our speed coming down? Well, on the return trip, when we are coming back down, it's traveling 2 miles an hour faster than when it was going up. So this is where we're going to say our upward speed plus 2. So this is the equation that we're going to try to build on. And I just put it in the same exact order of the r times t in the formula. Basically what you probably would want to think about doing is, again, putting the number in front of the variable. You probably also would rather see this 2.5 out in front of the r plus 2, so you can focus on your distributive property. They're both saying the same thing. So now we want to kind of simplify and get the variables on the same side. So my first step here is to use my distributive property. 2.5 times r is 2.5r. 2.5 times 2 is plus 5. Now I need to get my r's together, or the variables on the same side. So what I'm going to do is subtract 2.5r from both sides. That's going to cancel the 2.5r's on the right hand side, leaving us with the 5. And on the left hand side, 3r's minus 2.5r's is 0.5r, or half an r. Again, we're still trying to solve for this r. We're still trying to figure out that speed. So here we're using our inverse operations. It says to multiply by 0.5, so we're now dividing by 0.5. That will allow me to cancel. That becomes a 1, leaving us with the r that we're looking for. And 5 divided by 0.5, don't get caught on this one. It's not cutting it in half. Dividing by a half is the same thing as multiplying by 2. So that's the speed we're traveling at. We're traveling at that speed, miles per hour. However, the question is basically saying, how far do we travel? Well, r is not our distance. R is just the speed. So we have to go in here to our distance, because that's what we're looking for, and it equals our rate times our time. Okay, so our distance, the rate we just determined was 10. The amount of time that we are traveling is 3 hours. And because we are doing that, our distance is going to be 30, and we are working in miles. And the reason I used that 3, in case you're wondering on the time, is because the question was asking how far are we traveling upstream, and the upstream, remember, was the blue. So the question is asking how far do we travel upstream. The answer is, based on the fact that we're traveling 10 miles an hour going upstream, it's 30 miles that we are traveling.